the warm-up. So for problem number 1, we have the square root of 120. Square root of 120. So remember, you guys can have this paper out for the meantime while you're doing your assignments to look through to identify the largest square root that can go into 120. So the best thing that you guys can do is start backwards. So obviously it can't be 121, it's not a factor. 100's too big, 81's too big, 64 is even too big. So then we're going to work backward and say, okay, can it be divided by 49? Can 120 be divided by 49? Yes or no? No. Okay, what about 36? Can it be divided by 36? No. What about 25? No. So when we keep working backward, we're actually going to find that the largest perfect square that can actually go into it is going to be 4. 4 is the largest perfect square. Now, if you needed to write out all the factors, you could do that. So like obviously 1 and 20 would be a factor, 1 and 120, but we don't want to focus on that. We could say 2 and 60. We could say 3 times 40. We could say 4 times 30. We could say 5 times 24. 6 times 20, and then 8 times 15. Those would be all the factors that are of 120. And again, the 4 is going to be your largest perfect square that can actually go into this. So when we split it apart, we're going to split it apart as the square root of 4 and then the square root of 30. Square root of 4 and square root of 30. Square root of 4 can be simplified to 2. So our final answer is 2 square roots of 30. So even though this is a pretty big number, its perfect square factor is still very small. Okay, what about for problem number 2? We have the square root of 500. What is the largest perfect square that can go into 500 evenly? 10's not a perfect square. 100. 100 is the largest perfect square that can go into it evenly. Again, if you look at your perfect squares list, 500, what's less than 500? You got 44. Well, none of those are going to go into it very nicely until you get all the way down to the 100. 100 is a perfect square, and the 100 can go into 500 5 separate times. So having that list helps you to be able to see what you can split it up as equally. So you have square root of 100, and you have the square root of 5. Square root of 100 is 10. And then square root of 5 stays square root of 5. So we have 10 square roots of 5 as our final answer. Okay, what about for problem number 3? Is there a perfect square? What's the perfect square that can go into 26? None, right? Thank you, Jair. There isn't any. If we look, 26, anything smaller than 26, it can't be divided by 25, can't be divided by 16, can't be divided by 9, it cannot be divided by 4. So the largest one is going to be a 1, but remember we said if your largest perfect square is a 1, then it just cannot be factored at all. So for here, our final answer is cannot be factored. So square root of 16 is as far as you can go. And then problem number 4, this is what we discussed yesterday. When we have a coefficient in front of the radical, you're going to pull the coefficient out first. So we're just going to ignore the coefficient for the time being. And we're going to focus on simplifying the square root of 150. Perfect square that can go into 150. 25. Good. So square root of 25 is the largest perfect square that can be broken up into 150. So it's 25 times 6. 25 times 6. Okay, now the square root of 25 is going to be 5. And then, of course, square root of 6 comes down. And then now is when we go ahead and utilize that coefficient. What do we do again with that coefficient? Multiply. So we're going to multiply 3 times the 5. 3 times the 5. So we're taking our old coefficient of a 3 and what became our new coefficient of a 5. And we're going to multiply those together. And that's going to give us 15 square root of 6. 15 square roots of 6. All right. So what we're going to be doing today is we're going to take what we know with our numerical radicals and we're going to add variables into it. So we're now going to be working with algebraic radicals, meaning that it has both numerical and variable forms inside. Okay, so let's go ahead and start our notes. So we're talking about radicals with variables, also known as algebraic radicals. So if I were to give you, and this is why I was saying it's best for you to learn how to do this stuff without a calculator, because you can't use a calculator when it comes to the variables. If you were to try to type in a variable into your calculator, it's going to give you 0 as your answer, okay? So it's not going to work. You need to know how to do it without a calculator. So if I were to give you the square root of x to the 4th, y to the 3rd. Square root of x to the 4th and y to the 3rd. What's important to know when you're dealing with radicals and variables involved, the variables tend to have an exponent with them. So like I told you guys before, roots are just inverse operations to exponents. And in fact, a root is a fractional exponent. So a square root is the same thing as an exponent of a half. A cubed root is the exact same thing as an exponent of 1/3. Okay, so they're just fractional versions of your exponents. So if you were to look at the square root of an even numbered exponent, if you have the square root of an even number exponent, it's the same thing as just taking the exponent and dividing it by 2. Okay, so if you have an even numbered exponent, then you can take the exponent and you can divide it by 2. So for example here, x to the 4th. X to the 4th is an even numbered exponent, right? Because 4 is an even number. So I'm going to go ahead and pull this apart and just write it separately as square root of x to the 4th. And if I were to go ahead and divide that exponent by 2, then I would be left with just x squared. That's all it states, that if you have an even numbered exponent inside of a root, a square root, then you just take your exponent, divide it by 2, and then get rid of the root. So square root of x to the 4th is x squared, which makes sense because x squared times x squared equals x to the 4th. Now, if you have an odd number exponent, so if the exponent is an odd number and, here's an important thing, it's greater than or equal to 3. If the exponent is odd and it's greater than or equal to 3, so obviously a 1 is not going to work in this situation. So it has to be a 3 or larger as an odd number. Then you're going to remove one variable. Of the power of 1. so that you can get the exponent to be even. Okay, so all you're going to do in that case, if you have an odd exponent, you're going to take one of the variables away and put it to the side. So you're going to take a y to the first away from y to the third. That will then make it an even exponent, and you can simplify the even exponent. Okay, so what I'm trying to say again is here, y to the third is obviously an odd exponent. I'm going to separate y to the third out by breaking it apart as y off to the side. And if I remove one of the y's, how many am I left with? 2. So that means I have y to the second power here. Well, then, like I just said before, if you have an even exponent, all we have to do is divide that by 2, and it gives us our square root. So y to the first power. Now, of course, this square root of y is now going to come down like normal as square root of y. So our final answer when we pair all this together is just x squared y. I don't have to write y to the first. It's just x squared y and then square root of y. X squared y, square root of y. There's our final answer. Okay, so let me go over it one more time. If you have an even power, you're just going to take the power, divide it by 2, and then that's your square root. You get rid of the radical sign. So that's probably one of the biggest mistakes is people forget to get rid of the radical sign. Once you've taken the square root of it, the radical sign is gone. If you have an odd exponent, you remove one of the variables and put it to the side, and then you just take the even powered exponent by dividing it by 2. Okay, so you'll always, if you have an odd exponent, you're always going to have something inside of a radical left over then. Okay? Let's take a look at another example. Let's say that we have the square root of x to the 5th, y to the 8th. X to the 5th and y to the 8th. I'm going to zoom in so it's a little bit easier for you guys to see in the back. Okay, so let's start with the square root of x to the 5th. That is an odd exponent. So I'm going to go ahead and highlight it in green because it's an odd exponent. So it's not a perfect square to start with. So I'm going to separate it as x to the 5th. Now I need to go ahead and break x to the 5th up. I'm going to remove one of the x's. By removing one of the x's, that means I'm going to be left with x to the 4th. So I have square root of x to the 4th, and then a square root of x. Now, square root of x to the 4th, though, is a perfect square. Square root of x to the 4th is a perfect square. When I take the square root of x to the 4th, again, all I'm going to do is take the 4 and divide it by 2. What's 4 divided by 2, guys? 2. So that becomes x to the 2nd power. My square root of x is just going to come down as square root of x. Okay, now I'm going to focus on the y to the 8th. Is y to the 8th a perfect square? Meaning, is it even or is it odd? It's even. So if it's even, it means it's a perfect square. If you have an even exponent, it makes it a perfect square. That means that you will not have anything remaining inside of a radical sign. So we can separate this out as y to the 8th inside of the root. And then again, all you're going to do is just divide that by 2. What's 8 divided by 2? 4. So that comes down as y to the 4th. No radical. You've gotten rid of the radical. But now I don't like to have a coefficient in the front and in the back. You've got to piece them all together in the front and make it algebraically ordered. Okay, so my final answer is going to be x squared y to the 4th square root of x. That's my final answer. X squared y to the 4th square root of x. I want you guys to try these two on your own. You're going to have square root of x to the 6th, y to the 5th, z to the 7th. The square root of x to the 6th, y to the 5th, z to the 7th. And then problem 4, you'll have square root of a to the 4th, b to the 10th, c to the 9th. A to the 4th, b to the 10th, c to the 9th. Go ahead and do those two on your own. All right, let's go ahead and go over for problem number 3. So we have square root of x to the 6th, y to the 5th, z to the 7th. The only one in here so far that is a perfect square is which variable? The x to the 6th. Yeah, x to the 6th is the only one that's considered to be a perfect square because it is an even numbered exponent. So we can go ahead and separate that out right off to the bat. That's going to become square root of x to the 6th. We would then divide that 6 by 2, and we're going to get that it's x to the 3rd power. Okay, no more radical. Okay, so that means y to the 5th and z to the 7th are both considered to be non-perfect squares. So we first need to find a perfect square that we can remove from each, which by removing one of the variables from each of them, it'll turn it into a perfect square. So y to the 5th and z to the 7th, I'm going to separate them out first individually. Then I'm going to separate them apart by removing one of them. So this will become y to the 4th and y. Then z to the 7th is going to become z to the 6th and z. Okay, so again, y to the 4th and a y is the same thing as y to the 5th. Z to the 6th and a z is the same thing as z to the 7th. We're just separating them so that we now have created two perfect square values. So square root of y to the 4th and square root of z to the 6th are perfect squares. What is the square root of y to the 4th going to give me? Y to the 2nd. Devin, you are on fire today. So you're going to have y to the 2nd, and then that square root of y is going to come on down. And then what is the square root of z to the 6th going to become? Z to the 3rd. And then square root of z is going to come on down. That's a good thing, Devin, what I said. That's a good thing, okay? All right, now we want to go ahead and rewrite it, piece it all together so that it's in algebraic order and so that our perfect square values are in front and our non-perfect squares, our radicals, are all underneath one roof. Okay, so we're going to go ahead and piece x to the 3rd, y to the 2nd, z to the 3rd, all in front. then I only have to write one radical sign, and underneath that radical, I'm going to put a y and a z. And there's my final answer. X to the third, y to the second, z to the third, square root of yz. Okay, let's take a look at problem number 4. Which variables up here are going to be perfect squares? A and B. A and B are our perfect squares because we have a to the 4th, that's an even power, and we have b to the 10th, that is also an even power. C to the 9th is an odd power, which means that it alone is not a perfect square. We'll have to create a perfect square factor from it. So let's first start off with the square root of a to the 4th. Square root of a to the 4th can be simplified down as a to what power? Say it louder. A to the 2nd power. B to the 10th, we're going to separate that. Square root of b to the 10th is going to become b to the 5th. Okay, c to the 9th, because it's not perfect, we're going to go ahead and split it up. We're going to split up square root of c to the 9th by taking one of the c's away. So that's going to become square root of c to the 8th, square root of c. Now square root of c to the 8th is a perfect power. What does it become? C to the 4th. Okay, and then of course we have square root of c. So putting it all together, nice and squished in, a squared, b to the 5th, c to the 4th, square root of c. Okay, so now what we're going to do is we're going to go ahead and add some numerical values as well as variable values into the problem. It's still the same process, still the exact same process for solving. You have to break the problem up though. You have to first work with your numerical value, then you work with your variable values. Okay, so let's take a look at a problem like that. So if we have the square root of 512 m to the 3rd power, square root of 512 m to the 3rd power. The first thing that I want to do is I want to focus on 512. So I'm going to separate this out. This is obviously not a perfect square. 512 is not a perfect square. So I'm going to separate it and work on it individually. And then, of course, m to the 3rd. M to the 3rd is also not a perfect square. So I'm going to work on it separately. Let's first start with the square root of 512. Everyone should have their perfect squares list out so that you can look through it and identify a perfect square that can go into 512 evenly. We're focusing on 512. Here's our perfect squares list. Obviously, it has to be a number smaller than 512. So that means you'd start at 484, which is way too big, and you'd work your way down. So again, start at 484, which is not going to work because it's way too big. Work your way down and check each of these. We've got 441, we've got 400, 361, 324, and keep going on down. When you think that you found a perfect square, the largest perfect square that can go evenly into 512, raise your hand. Amron? Very good. Square root of 256. If you take 256 and you double it, so 256 times 2, that's going to give you 512. 256 times 2 will give you 512. So you can split 512 up into the square root of 256 and the square root of 2. Now, the square root of 256 is a perfect square. What is the square root of 256? 16. So we get 16 square root of 2. That's as simplified as my numerical value is going to go. That's as simplified as that's going to go, okay? Now we're going to focus on our variable, our square root of m to the third power. M to the third is not a perfect square, so what I want to do is break it up to where I remove one of the m's and put it off to the side. And then I'm going to have m squared remaining inside of that radical. M squared is a perfect square. What is the square root of m squared? Just m, right? M to the first, or just m. If you take 2 and divide it by 2, you take the 2 and divide it by 2, that's going to leave you with just m. And of course, now we still have square root of m inside that root. Can I leave it like this? No, I cannot leave it like this. I've got to put the things that are outside of the radical, they need to be side by side. And stuff that's inside the radicals need to be under one roof, side by side. Okay? So that means we're going to take that 16 and that m, we're going to piece them together and we're going to put it in front. Then we're going to take one radical sign and we're going to take the 2m and put it inside. And there's our final answer. 16m square root of 2m. I want you to try this one on your own. I'm sorry, you cut off. Do you need her at the front office? I believe AY, she's outside. Yes, ma'am. Just pick something up. Yes, I'll send her right now. All right, go ahead and do problem 6 on your own. Square root of 200, a to the 9th, b to the 4th. Okay, let's go ahead and go over this. Does anybody want to share what they got as their answer? Eric? Very good. Congratulations, you got it right. All right, so first thing that we need to note is that square root of 200 and the a to the 9th are both non-perfect squares. So I'm going to go ahead and highlight those in the green. B to the 4th is a perfect square. So I'm going to go ahead and highlight that in my pink because it already is in perfect square mode. Okay, so now I'm going to go ahead and split all of this up. I have the square root of 200. I have the square root of a to the 9th. And then I have the square root of b to the 4th. So square root of 200, the largest perfect square that can go into 200 is 100. And it can go into it 2 times because 100 times 2 is 200. Square root of 100 again, that is my perfect square. So when I simplify it, it's going to come out to a 10. So I have 10 square root of 2 when I simplify that square root of 200. Square root of a to the 9th. If I remove one of the a's and put it off to the side, then that leaves me with 8 a's. So a to the 8th power. A to the 8th power is a perfect square. So when I simplify that, it becomes a to the 4th. Right? Because all I have to do is divide that exponent by 2. And then, of course, square root of a is still remaining. And then square root of b to the fourth already is a perfect square. That becomes b to the second power. Now I need to go ahead and rewrite it so that all of my perfect squared values come outside and my radicals are still remaining under one roof. So I'm going to pull out the 10, the a to the fourth, and b to the second. That's all going to go out in the front. And then inside of my square root, or my radical, is the 2a. And there's my final answer. Are there any questions? Any questions at all? Okay, so you guys do have an assignment. Again, it's going to be in the workbook because we don't have our computers yet. I did just email and they said that they're hoping that we'll get them by the end of the week. So, but we still have to wait. So go ahead and flip over to the next page in your notebook. It's 12 problems. Do not forget to do it. Those of you who did not finish your assignments previously, make sure that you are keeping up with them. Okay, for problem number 1, I'm going to read them out as I write them. It's the square root symbol, and you have m to the 5th power, n to the 3rd power. M to the 5th, n to the 3rd. For problem number 2, square root of 32, x to the 4th power, y to the 3rd power. For number 3, it's the square root of a to the 16th power. 16th power. Problem number 4 is the square root of 31 plus 5. All of that's inside of the square root. Let's see if you can figure that out. I'm sure a lot of you will. The square root of 31 plus 5. It's not a t, it's a plus. 31 plus 5. Number 5, square root of 80, x to the 3rd power. 80 x to the 3rd power. Number 6, the square root of 28, x to the 3rd, y to the 3rd. X to the 3rd, y to the 3rd. Square root of 28, x to the 3rd, y to the 3rd. Number 7, the square root of 147, a to the 7th, b to the 12th. A to the 7th, b to the 12th. And guys, we already did square root of 147 on a previous homework, so if you need to refer back to see what it was, hopefully you wrote down the correct answer, then you can always reference back to your old homeworks. So square root of 147, a to the 7th, b to the 12th. Number 8, square root of 216, x to the 8th. X to the 8th. Number 9, square root of 40, x to the 5th, y to the 7th. X to the 5th, y to the 7th. Number 10, square root of 36, x to the 4th, y to the 5th. 36, x to the 4th, y to the 5th. Number 11, the square root of 250x. 250x. And then number 12, the square root of 128 x to the 10th, y to the 7th. 128 x to the 10th, y to the 7th. That's your assignment for tonight. Start working on it now. You do have 13 minutes left in class.